a switching layer. That was the conclusion we had from this discussion, that at least it's not wavelength on demand. Bandwidth on demand is something that we have on top of the DWDM network. And this is also driven by what we saw yesterday, that the rapid speed of the line rate does not match now the client speed requirements. Previously we had a very static period for probably almost 10 years where client speeds were 10 gig and line rates were 10 gig, and everybody was, I don't know if they were happy, but they accepted it and they made point-to-point connections. Now we are in a situation that we had 15 years ago, where we have a DWDM network, and then we have a multiplexer or switching layer below, and we were used to work with that. So this is what we foresee will happen again, a more static DWDM, and then switching layer in between, and multiplexing layer. What we then did also, we talked about this, the layer 2 services that we are supposed to provide, and we talked about the flavor of that. And we saw a lot of carrier Ethernet presentations yesterday, and we discussed, is it needed and why do we need it? And coming me from the DWDM world, and I say, well, I think that what we are doing here is probably, from my point of view, we are trying to pursue the OAM functionalities that are in carrier Ethernet. That is one approach, but still we have this eternal discussion about the transport-oriented view of layer 2 services and the packet view. The transport guy says we want something that we can understand. Something is coming in on this port, it's going out on the other port, it's A to Z, it's similar to what we know. Another guy say, no, we need something much more flexible that can vary and be pretty good. So in the end, do we need carrier Ethernet? We talked about maybe not the carrier Ethernet for the A to B, but maybe the OAM functionality that are in there. Why 1731 could be something that can work on standard Ethernet switches. It's not there yet. Usually it's packed together with carrier Ethernet, if I understand it correct. It could be that implementing that in standard Ethernet switches could be some of the solutions that we want. And the work in PerfSonar, I suppose, is trying to join this in. Is that right? Mm-hmm. Yeah. So that could be something that could solve the issues of OAM in layer 2. Any questions so far? Okay. We talked about. See here. We talked about the inruns and the sizes of the inrun, and if there's a big difference in what we are requesting and the commercial providers. And one of the suppliers was so kind to say that it's actually level 3 and Google, and then it's the rest, and the rest is actually including us. So we are not that far from the tier 1 providers. So our requirements would probably be the same as they have, and as such the product roadmap should match the N1 community. So if we see something that differs in quite opposite direction, maybe for example the PTX, which we probably is too big for most N1s, it's probably because it's made for level 3 or Google. We had the
Can I ask a question?
Yeah.
I'm sorry, I'm not slow, but I thought I would forget it, but I can't. Why do you say why 1731 and Ethernet switches are not there? Why 1731 is a carrier grade, it's a carrier grade thing, and we're talking about carrier grade equipment here. So I'm surprised you're saying that it's not on our Ethernet switches, and I'm thinking you bought the wrong ones.
I wouldn't know because we haven't got those boxes. So I think it was a general assumption that the Y1731 was packed together in larger carrier Ethernet boxes that has maybe the MPLS TP, or were focusing on another market. Maybe we could be that we needed more or less push down to, let's call it, the enterprise switches.
Yes, but even in enterprise switches you would find it.
Okay,
maybe
fine.
Not the top notch, I'd say something CCM at 3.3 milliseconds, but you would have it.
Okay.
I think.
Yeah.
I mean, unless
it's coming. It's only really on the very latest.
Really?
Yeah. Like EX doesn't have it.
Okay. Yeah.
Most of the Cisco cat line doesn't have it.
Yeah, but that product is 15 years old, right?
Correct, but that's the one that's out there and used extensively and fills the industry.
Okay,
If you talk
that's
about
why
new
we have a
boxes-
job, because we're about to replace them all, right? But I mean,
Lovely.
well, the thing is that I'm really surprised you're saying that, and that you're saying that as well. We have it.
So all the new boxes
Sorry.
do, but that's not what's out there, and not what gets used, and not what gets things. You know, we're having a lot of fun at the moment, putting boxes next to existing enterprise gear that doesn't have it, just simply to upgrade the OEM.
Wow.
I think also the approaches now, Alberto, please correct me if I'm wrong, the testing you have done with the, what's it called, the standalone boxes beside everything else?
The IST boxes.
IST boxes. And if you have standalone boxes monitoring stuff that actually could be monitored inside the actual end device, to me it's a kind of, why would have...
IT would not agree with that. You're monitoring a data, you have a blind eye, right? If you take all your OEM traffic outbound,
yeah,
and this is not monitored OEM.
Exactly, and that's why I think the stuff should be in there. So if we are pursuing, that was the whole discussion here, what are the entrants pursuing, and in the layer 2, are we just pursuing the OEM and not the you can say the MPLS-TP if we doesn't care what the flavor is? Why not just include the OEM in the current plain vanilla Ethernet or the boxes there? And forgive me if I didn't know the entire portfolio, but it seems like it's not present on all boxes, and if we're pursuing the OEM functionality alone, then...
So onto the TP point, maybe you implicitly already answered. What is the value that TP would bring to this community?
Yeah,
and I actually, this is to the room, not to the room, you know, to the room, because I only hear about TP talking, or you know, in one of what is it? What is the perceived or the real value that you guys think that TP would bring? It's a simple question, guys. Not all at once.
You mean MPLS-TP?
Right.
Yeah.
Yeah. Is it the lack of control plane that is really exciting people? Is it?
I can give an answer to that. I mean, a personal answer. I don't think the airline community is especially excited about MPLS-TP. At the contrary, most of the people I talk to that today are working with IP MPLS networks. They don't understand why they should go to MPLS-TP, and they just want to continue working like they're doing today. And those people that are working with the legacy networks like SDH, they think their next step is OTN. So
it's like TP is going to fall in between, like the IP guys.
Yeah,
these guys go like, I'll go with OTN. So TP.
It doesn't. I don't see it that there is a big demand for it.
The reason I'm picking it up is I saw in every presentation talked about TP, except mine. I just think it and we talked about it a lot. It's just why. The only reason that I would say it's motivational, it would be the OEM actually. The OEM exactly, because you don't have it in. Well, let's be honest, IP MPLS doesn't have a solid OEM. We have VCCD, we have LSP ping, but you know, there's also it's initiated. The OEM that you have in an SDH network is much more solid. TP fills that gap. Yes, I can agree with that. That would be good. Yeah, I like that. Okay, but you guys are saying we don't really give a rat's.
Well,
you know.
So Surfnet has chosen for a carry Ethernet solution. Coming from an SDH environment to maintain the static provisioning of services on our network. And that's why we chose for PBT or carry Ethernet solution, and it turned out to become a PBT network. But for the same choice, we have an MPLS-TP network.
And if I summarize, we like the. Well, sorry, that's sarcastic. You do not need the dynamic control plane, so you don't really need a control plane, but you do want to be able to statically, manually configure it.
Yep.
And you need OEM function on its respective layer. For you, it will be probably Y1731, AG, AH, this type of stuff.
Yeah.
Okay,
Yeah.
I find that good. Yeah, that's
Okay.
exactly. Yeah.
Yeah.
Okay. Do you have? Can you summarize?
Yes, I don't have the big network picture, as you can say. See here. We discussed, as I said before, we needed, of course, DWDM layer on bottom. We expected it to be quite static, and then MPLS, IP MPLS layer as well. And then the switching layer, we didn't discuss the flavor. It's needed depending on the size of the network. With regards to the let's call it the mobile network, we more or less said it doesn't change the design much. It's just a wholesale handoff point from our point of view. And also, if you create your own cloud services, it's just another handoff point. It's nothing that we would change the network. We can come into a discussion of either you have the cloud, you create the cloud yourself, or you carry your network to the cloud, as Nordnet has done by making increased peerings in the US to get closer to the cloud providers. But that's something a little different from the network build out, I would say. That's the peering policy and so on. So this is that was summarizing it.
Okay. Were you speaker for group 2?
Yeah, well, freely elected and volunteer as they call it.
You know, you just stole 5 minutes from yourself.
Yeah, I know.
That's the plan.
No, it's okay, but we should try to manage so we get time for everybody.
A longer hand.
I'll make it very short.
Yeah.
You know, so this is our. We had another slide. I'll check it. So basically, we're team number 2. We got a bit stuck with the task because it was like a very simple question, and the more we talked about it, the more we realized, like, holy moly, you know, what did we get ourselves into? I just wanted to say that whatever Lars has summarized, we actually came to a very similar conclusion. Then, of course, the question was also brought up: is that academically, how many nodes are we talking about? Because the scale is important. Then the other thing we talked about is, let me collect my thoughts. We talked about, actually I should explain this example, then, because we spend most of the time on that. This is for data centers, and there are a few, what technology should we use? And we came to a conclusion that there are at least 2 axes to the discussion. The first one is that you have an Ethernet switch, you have an OTN switch, and if you need to carry like 32 gigs of traffic from east to west, left to right, and it's bidirectional. That's another problem with IP MPLS and TP and GMPLS. So if it's bidirectional and I need 32, I can put a wavelength in here, but then if I put a wavelength in here, then I only have one wavelength here, I have one thing. You know the limitations with that. If I need to have another flow 22 gigs down, I would need to put another gig, a 40 gig in. Alternatively, what we can do is put an 100 gig to each side. So this is a kind of a hub site, hub and spoke technology, architecture. It doesn't mean that we need to have one. We can have multiple. Then we have kind of geo redundancy. What we do is then we kind of carve up our 100 gig or 400 gig, ODU5, it doesn't matter, but we carve up our 100 gig into time slots that we can allocate, and that is called ODU flex, or we can simply say we use ODU zeros. Now ODU zeros has a disadvantage, it's kind of 0.25 gig less, but that's not the point. The point what I want to make is that 100 gig comes in here, we have assigned 32 gig, and with the number of time slots we accommodate for this request, for this flow, and it goes down. It's just flow based at the end of the day. It's virtual concatenation in one audio flow. So the other one goes simply through. I can explain better. I didn't do very good here on explaining. But so one technology could be, first architecturally we have a central site or multiple. Secundo, because we can also say we can fork and make it resilient from here out. Forget this central site. So that's the architectural. The other thing is then on which layer we should switch. Should we switch or groom on the ODU layer, or should we switch and groom on a packet layer? Now obviously there is a cost factor associated with it, but essentially it's the same. If you switch on the packet layer, you then, okay, if you irrespective on which layer you switch, you then need the implication is that you need to start thinking about your control plane, your resiliency. Where are you going to put your resiliency? Are you going to put it in the lambda layer? Are you going to put it on the ODU layer or on the packet layer? And packet could be IP MPLS, MPLS TP, or Ethernet. It doesn't matter. They're all packet layers, and they have their own OEM system. That's all right. Is there anybody from Cisco here? Juniper here? No, huh? Okay, so Juniper has this whole idea about stat muxing, where you say this, I don't do the audio flex switch in here, I do the packet switch in here, because I have statistical multiplexing gain. Now, I do not bite, and my argument with that statistical multiplexing gain in the core is actually nonsense. It does not make sense. In the axis and aggregation, you can do stat muxing, but in the core, it's already stat muxed. You got continuous CBR traffic packet based. So our idea would be to go to an ODU switch here, ODU flex switch grooming here. Alien wavelength, which was also a requirement. So once everything is packetized layer 2, 3, we don't care. That comes in here. Alien wavelengths go straight into the WDM, and they're switched through here. They're glassed through here. Of course, we're not going to go and pop them out because we don't really know what is in the wave. So it goes through. And then the last thing we talked about it was, or the first thing, but equally important, was for the handoff for the mobile Wi-Fi. I'm not the expert. How am I doing in time? Good?
Yes, try to.
Okay, so this is it. That was it. No, I'm joking. Basically, and I think you also said it, for the authentication and all that, for cloud and for the Wi-Fi offload, all the infrastructure need to be put into place. Most of it, I think, is already there. I think, but I'm not the expert in there. So we came to the conclusion, login, password should be sufficient to actually direct you to the appropriate radius. I just want to take one more thing. For the data centers that we have here, the infrastructure could be, because the problem that Marcin brought up is that I'm sitting there as a network operator and I need to see my bandwidth requests come in because I need to do bandwidth on demand, right? Or I don't need to, but I want to. So who's going to trigger me, i.e. the network, to say establish a path? And the idea could have been is that I have a central controller that one says, listen, I'm going to bring my data from this side to the CPU side with the virtual machine where I have a lot of data. And then I can log in, point and click and say, I want it. That controller then could talk to an SDN controller and then could go and provision either each individual network element itself, or say, go find a path and let GMPLS do it, or via PCE, and there are different ways of doing it. That's it.
Okay.
You have questions?
What's the value about OTN in this? I mean,
What's
what's
the
the value of OTN in this scenario? I mean, you could even replace it for SDH, and then we're back 10 years ago.
Oh, absolutely. The problem is that you don't have SDH on 100 gig or 400 gig, right? It stops at 10, maybe 40. Sorry. The value. The thing is, I'm not going to argue whether it's right or wrong. I'm not going to get into that discussion, but the value I can see, I can argue that, is that I can have a central site that does ODU flex. So, and it's exactly the same like VC4s and all that switching that you have, STM, absolutely. But you have the OTN underlying layer, and OTN is the next gen SDH. So whatever you're going to say good about it or bad about it, it's going to apply here as well. So, and the other thing is then, or the other alternative, again, not good or bad, is just an alternative, is I do the packet switching. I don't do any ODU, I just go from single lambda, terminate the ODU, look at the packet decision, and then dump them back into the optical layer. It's an alternative.
I think it's important to say also that the waves are, or the transponders are integrated into the OTN switch. So you have that functionality where you can better utilize the waves using the OTN functionality. So you're not having the traditional way of having a client interface on the transponder, a black and white interface, and then going into a line side. The switch sponders, which Lehman were talking about, are directly integrated into the OTN switch, and the client interfaces can then be locked into these 100 gig waves. So you're utilizing your 100 gig waves much better in the network.
But still you need an Ethernet switch next to that OTN switch?
No.
Or is it integrated in one device?
Well, you need to have something that actually, you will have anyway, a packet device here,
but
right?
not in the core.
In the core, no. We would eliminate that one.
But your customer's there as well. I mean,
Oh no, yeah, right, no, stop. If he's there, then this side becomes this side, because it comes one of these. This is actually, and you can, and typically you are, and you have, but it does not necessarily need to be. Yeah, you can. That's it, no more questions?
The
post-its are falling.
You need a hand to wait.
Can you click it on here? I don't think I'm going to use it anyway.
Oh, it's there.
So actually, this one. Yeah, it's okay. So we had this is group 3. So we had a discussion. We were not really structured, but we took some notes, and I'm trying to summarize the discussion we had. So we started discussing what and asking what do we need in the layer 0, and we all agree we need DWDM. But then since we're going to have very big bandwidths, 100G and 400G, we need some. We all agree, and it was probably common that we need some kind of switching layer. And the only technology to date that can do that is OTN for that layer. So we agree that OTN is probably the right choice to do the switching for various reasons. First, it's flexible. Secondly, it has the TCM functionality. So the OEM was something that very important for this choice. And I think there was it's good for service demarcation. I think that was a comment from Jeff. And we saw that the OTN switches are quite big platforms with a huge switching capacity. So probably we're not going to need this switching capacity everywhere. So today there are architectures, providers are providing are manufacturing equipment that where they have the photonics integrated with the OTN switches, and there are also other solutions where you have the photonics and then you have apart the OTN switching. So we found out that it could be a mix of these two depending on your network architecture and depending on your needs. So we also came to the conclusion that the control plane GMPLS was also something that we will need. However, we found that there's a challenge to use this in a multi-domain environment. Could be nice, but mostly was for single domain use. Coming up to the next layer, we also started discussing what kind of layer 2 technology we wanted to use, and we could see that there's different needs. People like certainly they are using PVT, other airlines are using Ethernet or MPLS, other are going for MPLS-TP. So it's going to be very, very difficult to connect all these technologies together. So, but on top of that, everybody's using Ethernet. So I think for interconnection in layer 2, for layer 2 services, for interconnection between endpoints, it's probably going to be Ethernet. And in that sense, Ethernet OEM came within also is quite relevant, and we should start using it more often to monitor end-to-end connections. Then we talk a little bit about the applications, and that might have, and I think one of the applications was high-frequency transmission for applications like seismology and metrology, and this kind of application can have an impact in how the network is going to look like. In which way, I think we didn't got so deep into the discussion, but definitely was important.
What was the application?
High frequency transmission.
What does that mean?
Maybe someone here can explain.
High frequency trading, you mean?
Yeah.
No, this is the metrology application.
Yeah.
It's not the financial stuff.
No,
it's some native.
Some of the photonic guys.
Oh yeah, the photonic service you mean?
Yeah.
Yeah. Transmission of signals that are not. It's not data signals. It's maybe a pulse that you are using to synchronize atomic clocks or observation instruments.
And how would you transport? Not on a packet layer though.
No.
Analog. Yeah. Fully analog.
It's analog on the optical layer. Then.
On the optical
Okay.
layer.
Okay. Yeah.
So.
Yeah.
So we also saw the need for exchange points based on Ethernet, and actually there are projects in the NRAN community about that. It's called federated hub. So this is also something that instead of connecting in different NRANs, so there will be a centralized point for interconnection for different NRANs, and that could be a solution for that as well. I think I'm running out of time. there was some discussion as well about bandwidth on demand, and one of the comments were that the demand for services is not so high enough to have a need for bandwidth on demand. So it's a nice to have application, but it's not really needed due to the amount of requests that we get in the NREN community.
Could you summarize that, saying that I do not need bandwidth on demand because I have over-provisioned my network?
No, it's not because you have over-provision, it's because the amount of service requests you get doesn't, it doesn't really, you cannot, the investment that you have to do to have bandwidth on demand and all the working hours to have it installed and get it working doesn't really, if you only do one connection a year or a month.
Oh, so you're saying that your dynamicity
is
low.
Yeah,
your churn is low. Okay.
Yeah. Maybe I could find better words, but the reason is that the amount of services are not high enough.
Yeah. So once you set it up, you leave it.
Yeah. So, but it still is a nice to have feature in the
sorry, just for the sake of discussion, bandwidth on demand is not only connectivity on demand, what you're talking about, i.e. I have a connectivity of 10 gig.
Mm-hmm.
Bandwidth on demand is that I only need 1 gig today, but tomorrow I need 20 gig. Is that an application you see? I guess
that's a question for everybody. Yeah.
No, we discussed it, and the policy of Janet bandwidth on demand team will be discussed in December in Utrecht, but I saw a draft document for this policy. So current suggestion is to allow, as we described, to end users to request bandwidth very dynamically, but up to some limit. And bigger bandwidth will require more bureaucratic procedure with approval from NOx and so on.
Okay, so you're saying to bandwidth on demand, there is also a kind of a procedural impact, i.e. I need to ask him, which
for some big connections. Some modest connections won't require any approval procedure. We will do it quite quickly.
Thank you.
I think it's one of the things that we ended up discussing was that the users want bandwidth on demand because they want to pay for it when they need it, but then they don't want to pay for it when they're not using it, and the eternal challenge of how do you make it pay when you're not using it. You know,
that's where bandwidth on demand would make sense, I would say,
and you know,
accounting.
And it's generally a money problem rather than a technical one. And lots of people have tried, and as far as I can work out, even the NRENs and the service providers, it hasn't really worked.
There is a technical aspect to bandwidth on demand, and that's to solve the multi-domain stitching problem. So we've got Ethernet of different technologies and different NRENs, and you want to build a circuit across Europe or to the US. It basically stitches together via a kind of an overlay, sort of multi-domain overlay. It can stitch together all these different Ethernet technologies and automatically provision. So from my point of view, bandwidth on demand is really a provisioning tool for the NREN community that allows this multi-operator environment. So we're not in a situation like Google where we can have one network management system or one control plane. Okay. Every NREN has its own technology, and that's really the driver behind the bandwidth on demand.
Because as an industry, we've been trying to solve this since mid-90s. The US inbounds who wanted SDH and Sonic connections into Europe and want to be able to provision various national networks. We've been going around in circles for a long time. Generally, there are solutions out there, and we can solve that. And the multi-domain one is a really interesting one, but you have to sort out how the money works, because that's what's killed it every single time.
It's funny, I had the same thought. It's like, how long have we been doing this now? And where are we? And we still haven't figured it out. It's like, God. Anyway, okay.
So that was, I think, it. Is it group 4 now? Is it Are you number 4, number 5?
I'm number 5.
Okay. So
I'm number 4.
I'm not sure if you're going to see this properly.
The answer is no. Yes, you're right. We don't see it properly.
So I'm going to explain this to you. So actually, can you please stand up? I'm asking my teammates just to make yourself known. So if I'm talking rubbish, please blame these guys. So actually, we're pretty much focusing on a national situation, and we try to build up the ecosystem where the NREN should work, and we identify some players. And so on the user side, there is the NSIs, the universities, research institutes with the campus network and campus Wi-Fi. At the same time, there are the mobile networks there, and the users are mobile actually, and in some cases they are using more and more mobile devices with a SIM card. So some of the traffic goes to the mobile networks via the commercial ISPs, and then to the public or commercial cloud providers. So that's the part of the traffic which does not really touch the NREN network at the moment. So we said that it's a kind of a challenge that we have to address, how to migrate that mobile traffic to the campus Wi-Fi, and how to catch that traffic within the NREN network and tunnel it back to the mobile providers or commercial ISPs or whatever. So this is one of the challenges that we set. Another challenge is on the other side, there are the public cloud providers outside of the country in the cloud, also the big science data, CERN and other big science institutes. They're buying big pipes. They do some collaboration with the national data centers. Most of the countries has a national data center. So it's somehow the role of the NREN to interconnect those parties as well. It's a kind of challenge again. And the third challenge that we said, if we talk about services and we talk about layer 1, layer 2, layer 3 services plus bandwidth on demand, then I think it's fair to say that most of the traffic is on layer 3 at the moment. So at least 80–90% of the traffic. So the other services that the NREN is trying to attack is quite small at the moment. So that's another challenge, to convince the end users to use something else. Maybe they need something else than IP. Maybe they need a layer 2 or some other services. They just simply don't know about that. So, and I think it's fair to say that the NREN is small. So these are all big players. In some country, for instance, in Spain, there is a Spanish university, I can't remember which one, which has more students than the entire student population in Slovenia, which is a country. So there are big players here. Even the university campus network could be bigger in some cases than an NREN in another country. So I think it's fair to say that NREN is small, and this was the assumption in this report, that it has to grow 50% in terms of traffic, I guess. So we came up with an architecture which fits into this national ecosystem that we drew up. We didn't really think about multi-domain issues, although I fully agree with those issues that you just mentioned. So we came up with an architecture which is flexible enough, easy to operate, and can address these challenges that I've just described. So from bottom up, so the NREN need lease dark fibers. They don't want to own the fiber, operate the fiber, measure the whatever signal to noise ratio, and fix the cable cuts. It's not the role of the NREN. They just need reliable, good quality fibers, so leased fibers. It's the opposite on the WDM side. So the NREN needs to own the WDM network, so they're not going to go to telcos to rent some LiPAS services. So that's going to be owned by the NREN, and they need good quality DVDM. We said near Shannon limit WDM network. That's what they need. And on top of that, we imagine OTN layer, an MPLS TP plus IP on top, and then a GMPLS control plane that controls all these layers: IP, MPLS TP, OTN, and the WDM on top of at least a fiber network. And then we came up with an idea how services can be mapped to the network technologies. So I'm not going to describe that, but please go to Kurosh. He came up with this idea. So basically, if you want to provide, for instance, Ethernet services, you can provide layer 2 services you can provide. On top of this architecture, you can provide those layer 2 services on any layer that you want. So there is no Ethernet in this architecture. So for instance, Ethernet can go over IP or whatever over GMPLS. If you're familiar with the notion of encapsulation and tunneling and stuff like that, so basically you can map almost all services into almost all technologies nowadays. So that's that's the imagination of the NRAN, how these services can be provided to the NRAN. So this is more or less our architecture proposal. These are the challenges, and we didn't really talk about the operational challenges and stuff like that. We just said that this network should be easy to operate, and there are many operational models. Could be outsourced, could be done in-house. Half of the operation in-house, other half outsourced, stuff like that. But at least the architectural design part of it should be kept in-house, and that's what this terrain architecture workshop will discuss starting from the afternoon. A little bit of promotion here. So that's it basically. Questions? Not to me, to them.
Yeah, one question to the Ethernet. I don't need Ethernet, or in this architecture there's no Ethernet?
In this architecture there's no Ethernet, that's fair to say. Although you can provide Ethernet services on top of this architecture if you tunnel in.
Over transport, like IPUT also, yeah?
Yeah, for instance.
Well, the MPLS,
MPLS TP.
Or MPLS TP, yeah. Or over IP, so there's
So
strange Ethernet over IP as well, if you want.
So what does the TP box has got the DWDM photonics in it as well? Or are they two boxes and you join them with Ethernet?
it's not a box, it's a layer diagram.
Okay. It's no boxes, these are the layers. It's yeah.
I think
Over
you might find there's some hidden Ethernet in there.
Yeah. I mean, it's to interconnect, but I don't think that I just get from one intermediate to another intermediate. But overall, I think what they want to see is this.
Okay.
I mean, we do that, right?
Okay. So it's number 5.
So they take this one.
Okay, so we kind of spent quite a bit of time at the beginning trying to work out what the assumptions were, because as you'll see when I get into the layer 1 thing, the assumptions you make about the size of the network make quite a significant difference on the solutions that you choose. So essentially the kind of things we assume the services that were described in the document, which is the wavelengths, layer 2, layer 3, bandwidth on demand. We assumed that there were some big science users and some regional networks. We assumed the 50% growth, and the interesting point there is we assumed for a reasonable sized country with say 30 POPs that if the day 1 IP trunk capacity between POPs was 20 gig, we did a quick calculation on 50% growth on that IP. That turns out at the end of 10 years, you've got a factor of 25 growth in your capacity. So the number of 10 gigs you'd need to deliver your IP in your core grows from 2 by 10 gig to 50 by 10 gig. So that's a lot of capacity. So we need a solution that will scale up to that. And then so that's essentially the assumptions. Then we went straight into looking at layer 1. And we got quite controversial at that point. This is where the scaling assumptions become important. We all agreed that 100 gig was essential, and then the question was: do we want to support alien waves? What style of ROADM? Colorless, contentionless, or even digital? Gridless and GMPLS, are they all technologies that are needed? And the challenges we considered was how do we deliver 10 gig and 100 gig simultaneously? Now, I think Jan Radl made the point that if we start putting 100 gig everywhere from day one, then it really causes a problem in scalability. So if you've got requirements for 2 by 10 gig, it's very expensive to put 100 gig in, put OTN on top of that to break out 2 by 10 gig. So he had some questions about whether that scales, particularly for a smaller MN. So actually we came up with 2 solutions here, solution 1 and solution 2. So the majority decision was solution 1, which was to use 100 gigabits wavelengths with no DCM, so that eliminates the possibility of using 10 gigabit waves, and then requires an OTN solution to give you some sort of TDM. Alien waves become possibly. Sorry.
But you
so
can do 10 gig without DCM.
No, you cannot.
You cannot. So by making it DCM free, it makes 10 gigabits quite hard to do, or pretty much you need coherent 10
You
gigabit,
have a
which
product that will do 10 gig over DCM-less networks.
that's a max bonder 10 by 10.
That's not a good design.
I guess.
Okay, but to say you cannot do it
Okay.
is unfair.
All right. Okay, so that was let me emphasise the majority decision was DCM free with 100 gig and use OTN, and I guess there'd be 10 by 10 max bonder is the option that you're talking about. Is that right, or are you talking about coherent 10 gig?
No, we have
Native
a
10 gig?
product that pre-compensates. It's called EDCO. We've had it
Right.
for about 7 years now.
Right.
That allows you to run 10 gig over a DCM-less network. It's what we did before we started to move to coherent. It's not coherent. It's a
Right.
pre-compensated
Okay.
adaptive system. It's about 6-7 years old now.
Good. So that strengthens solution 1 then. Solution 2 was to mix 10 gig. Well, the solution 2 was to leave the DCM or have some kind of dispersion compensation in for use by both 10 and 100 gigs. So it seems like that's not necessary. There are products available that will mix the two. And then there's the margin problem with guard bands and problem. So so that was the layer 1. I think there was a slight tendency towards using OTN combined with GMPLS as a capacity grooming option. But that led to the challenge of integration between the layers. So how do you integrate your GMPLS with any control planes you have in layer 2? So down here under the questions we had PBT, Ethernet, MPLS, IP MPLS, MPLS TP. There was a strong consensus, I think, in our group that IP MPLS was the preferred option. I think that seems to be a movement in that direction generally within the NRENs. So then moving down to the next layer, there was a sort of discussion about if it's IP MPLS as is the solution, you've got a router platform there, and is there scope to merge layers 2 and 3? And there was some questions around the challenges there, operation design, partitioning, and monitoring. I think came in there as well. So a possible solution would be IP MPLS over a router. Then the questions around BOD challenge came up, and I think the general feeling was, correct me if I'm wrong, but the general feeling was that bandwidth on demand really suited that sort of layer 2, 3 solution, and didn't necessarily belong up in the layer 1. And my view there is the solution to make that work is NSI. So NSI will standardize and make all the different implementations of dynamic and bandwidth on demand systems work together. And then finally on the access layer, if you like, or it's not really a layer, access side of the network, the questions we asked were OpenFlow. What was this one? Mobile, how do we support mobile and cloud type services? So the challenge there was virtualization, and we moved into a discussion around VPN support and access wavelengths to deliver those services. So that's in general the view. So questions?
I'm very impressed with the presentation and the way you guys have done that, I must say. Very nice.
Right. Yes.
Wait, thank you. You said in your design that the choice is IP and PLS, but will be that with some of the new tools like OEM tools that are being developed, will that be considered?
It's a very good question. I think it kind of appeared under challenges rather than solutions, really. So we really didn't get into the discussion around OEM. But I think there's a recognition that it is something that needs more work. All right. Thank you.
Thank you.
So I think with this, the workshop concludes here. Actually, I would like to thank you, everybody, for attending the workshop, and I hope you found it useful. This was, I think, a very good opportunity for Tony's activity to present the results. But that was not the only purpose. I think it was a good idea to gather people, experts from different environments to talk together, and I personally found it very interesting. So thank you, everybody, and now thank you also to Alcatel, Infinera, and Sienna for joining us and giving us some good inputs as well. So thank you very much. And yeah, I don't know if it's if you think this is a good idea and you found it useful, maybe we can do another one for GM3+.
That's the intention.
Okay.
Yeah, so we'll do the same.
Okay. You will organize it.
I will organize it.
So yeah. By the way, we will try to gather all these ideas. We all this was video streamed, but we also recorded. So we will look into it and try to summarize, and we will try to put in a white paper at some point, and we will make it public in the GM3 homepage. Now we have lunch, and I think after lunch we start with the Terena Architects network architecture, and that will start one at 1:30, right? Sure. Okay, so thank you.